Quick video just trying to describe making sure we're all on the same page with these terms: heat, internal energy, and temperature. So for this class, I want you to think about internal energy as the motion of the molecules in a compound. So let's say you had some matter here and it's wiggling around. The amount of motion here, where is it? There we go. The amount of motion of these molecules correlates to its internal energy. Now, strictly speaking, there's also chemical bonds, nuclear bonds, other forms of energy like that that you could associate with the internal energy. But certainly for this class, and maybe I should add in, for this class, this chapter, it's pretty good to associate internal energy with the motion. So, for example, 1/2 mv squared of a molecule relates to that particular molecule's internal energy. There's also rotational energy, things like that. We'll get more into it later. Associate internal energy with motion of molecules. Heat is different. We're going to use the symbol capital Q for heat. Now, both of these are in joules. All right. I want you to think about heat as a transfer. So a lot of times you'll hear people say heat transfer, heat transfer, heat transfer. That's not bad. I like that. Just constantly thinking about heat as a transfer of energy from object one to object two. So I don't think of heat as something you store. Probably that feels a little weird to you, right? You could imagine heating up a pot of water and saying, oh, I'm storing that heat for later. But really what I would say is if you heat up a pot of water and let it sit there, you transferred heat into the water, or you used a heat transfer into the water to warm it up. Then it has more internal energy, and that internal energy could be used to heat something else later through a different transfer. Subtle, but I think it's worth remembering. So think of heat as going between the objects, and the objects have internal energy. They don't have heat. Heat is the transfer between them. Lastly, temperature. Temperature is directly correlated with E internal. So it's a measurement. If you measure something's temperature, in theory, you could use that temperature measurement to estimate some sort of, usually we do changes in temperature to estimate changes in internal energy. Calculating the internal energy is actually very difficult because you can imagine this stuff gets very difficult, but we can use a temperature change to measure a change in internal energy. So really I should be saying delta T corresponds to delta E internal. That's really the thing that we want to associate, all right? But in general, if you have more temperature, you should have more internal energy, and you should have more molecular motion for a given substance. All right, you could start with no. And right, you could think of my hand as transferring the thermal energy in and heating this up and causing more molecular motion. That's it. Now, a quick note on units up here. So there's calories, and then there's calories. These are the ones that we associate with food. But if you look on food wrappers in other places, so the capital C is a food calorie, whereas the lowercase c is just a calorie. And they're related. There's just a factor of 1,000 relating those. But so in other countries, you might see your food calories listed instead in joules. So, or kilojoules. All right. So those are some old school notes. In this class, most of the test questions, I'm going to try and use this. But if you're searching the internet, a lot of times you'll see some parameters are listed in calories.